All right, so here we have a rational equation, and this is pretty similar to the problems we've seen before. The big difference here is that I have variables in the denominator. So one of the things I have to consider is the fact that I don't like having a zero in the denominator. This is going to be a domain restriction because I know that x plus 3 cannot equal 0. I can't have that 0 in the denominator. So minus 3, and I find that x cannot equal negative 3. By the same token, I know that x cannot equal 1, because that'll get me a 0 in the denominator as well. But then when I look at this denominator, I can't really tell very easily what x cannot equal. So I'm going to go ahead and factor it, since that should make it easy for me to identify what can and can't go in the denominator there. Okay, so if I factor that out, I'm going to get x plus 3 times x minus 1. And oh, that ends up being the same as these, right? So I know that x plus 3 can't be 0, because then the denominator would be 0. And I know x minus 1 can't be 0. And this is also going to help me because I know that I need to find my LCM. And again, it can be a common multiple, but least common multiple is going to be the easiest route. So let me write out the rest of this, and then we'll eliminate that denominator. All right, now that I have it written out, what we're going to do is we're just going to multiply by all of the common multiples on the bottom. And so I have an x plus 3, okay? And that'll take care of this one. It'll also take care of that one. And that's enough. And I have an x minus 1. And I need to multiply both sides by that. All right, and now that I've done that, I'm going to go ahead and distribute it. And I'll kind of fast forward through this step so it'll be a little quicker for you. All right, so I'll be the first to admit this step might seem a little tedious and like I'm doing a little bit too much. And if you can do it without this, without making mistakes, go for it. But if you find yourself making silly mistakes with the distribution, just write it out. It doesn't take that much more time, and it's a lot less time consuming than making a big mistake. So now I'm going to eliminate the common factors on the top and bottom and cancel them to 1. All right, and now I will go ahead and rewrite everything, multiplying all of the remaining factors out. All right, and from here, it's mostly just fairly simple solving. So we'll go ahead and distribute, simplifying things slightly. Okay. Combine like terms. Then go through the rest of the solving. Now, I have solved my equation. I'm going back up here and I verify that it is not the same as any of those domain restrictions. So I'm not going to get a 0 in my denominator, but there's really no way to check this that's easy, at least currently. So what I'm going to do is I'm going to show you a graph of the right and left sides of this function. So we'll go ahead and call the left side of this function y1. And we'll call the right side of it y2. And then we'll graph both of them using a graphing utility and look for where they're the same or where they intersect. Keeping in mind, of course, that a point is x, y, right? So we're looking for that x value of the intersection. So let's look at the graph. All right, And here, if we look, you can see that I graphed y1 and I graphed y2. And then looking at these graphs, we might not know how to graph them currently. We'll learn how to do it later. But if you look at my x value, it does match up to be -4, just as my algebra implied. Therefore, I can say with relative confidence that my solution of x equals -4 is the correct one. And quickly, just to summarize what I did throughout this problem is first I identified any domain restrictions, okay, or any values that are going to make the denominator 0. Then I identified my least common multiple, or at least a common multiple, so that I could eliminate my denominators. And then I just went through and solved. And then I used graphical analysis to identify or to verify that -4 was in fact the solution.